Okay. Yeah. So what I wanted to say was that we have an exam coming up in 2 weeks, and I have posted some information under the content area under the folder exams. So that will give you some idea as to what the first exam is going to be like. There will be multiple choice, true, false kind of questions for about 25, for about 50 points. And I mean, roughly, it may not be exactly that. And there will be programming questions, pseudocode and all that stuff for the remaining. So there will be questions of all kinds. You need to master all the material that we cover in lectures 1 through 4. So what is a good way to prepare for it? Make sure that you can do all the class exercises, all the labs, all the assignments on your own without any help, and that you are able to do some problems from the book or some such things, then I think you should mostly be okay.
Mr. Gotham?
Yes.
Do you create a study guide or anything like that, or is it just problems from the book and stuff that we're expected to study?
I don't create a study guide, but there is a little document that says what the nature of the exam would be. Because everything we cover is required for the exam. So there is no specific topic that I can say this is more important than the other. But you should be able to develop programs, look at problem statements, and then see whether you are able to create pseudocode, test data, write programs. So if you are able to do the lab and the class exercise problems and the assignment problems comfortably, you should be in fine shape.
Mr. Dayton?
Yes.
But the multiple choice, they have to do with the readings we have done so far, right?
I'm sorry?
Multiple choice have to do with the reading, right? That's like posted in D2, right space.
It will be very similar to the questions in the class exercises and the quizzes before class. And there will be questions on the readings also, the other readings, the first 3 readings. Yeah. So questions would be very similar to that, but they may not be the same questions.
Okay, thank you.
Yeah. I can't really vouch for the difficulty or anything, because one could always argue as to what is more difficult and all that. So it would be very similar. And it'll be the entire morning will be for the exam. There will be nothing else going on that day. And you will have to have your video camera on, that is webcam on. If you don't get credit for the exam. So there is no argument about that. I mean, you can't argue with me that you can't turn it on or something. If it doesn't turn on, that's it. You lose credit for the entire exam. So please be sure to turn it on. You don't turn on the audio. And if you have questions, you should ask privately on the chat. And then we can go to a breakout room and then see if we need to talk. If you can do that. Okay. And usually 3-hour exam, many students finish in an hour and a half. So I don't expect the exam to be long, but if you are not comfortable with the material, it can take you forever to do those questions. So few questions you can ask me about that, but
I just had like one quick question with the exam. I just want to know if it's like a yes or a no. Do we use our notes on the exam or no?
Oh yes, you can, yes.
Oh, notes are allowed on the exam?
Notes, textbook, everything. Yeah, you can use that. You can use all of that. The only thing you cannot do is communicate with another human being.
Okay.
Yeah, you are not allowed to do that. Okay.
Okay.
Yeah, right. It is open book, open notes, open everything. You cannot ask questions on the internet. You cannot email. You cannot use WhatsApp or text messages or any of that kind. Now, what I want to do is talk a little bit about the subject material, things that I have noted in the assignments and um, labs and all that. And then we will talk a little bit about the material for this week, and then you go to the class exercises and then labs. So what I'm going to do is actually talk about test data, pseudocode, variables, coding, etc. But for that, I'm going to use the lab for this week, just to give you an idea, okay? So that I will be explaining the lab as well as talking about the things I wanted to emphasize. So you have multiple things achieved with one thing. All right. So let's talk about the lab for this week. You have to write a Python program that reads in information related to a rectangle and prints out some values. So when you should read, when you read the problem statement, you get an idea, and you should look carefully as to what the output is. The output has to have 2 lines that are printed out. This is not information about the program for you to understand. This is the message that the program prints. Notice that the program prompts in a certain way. So it is not enough that you simply say, give me the length or that's some such thing. It has to be exactly like this. Your output must conform to what I specify as a user, right? In the profession of computing, when you develop programs, you are meeting the needs of the user. You don't tell the user, this is what I'm going to give you. You listen to the user, understand what the user is telling you, and then giving them what they want, not what you want. So here I am saying the program should display these 2 messages or these 2 lines. And then it should prompt this way, enter the length. You cannot say length, or you cannot say something else. It has to be exactly this text. Now notice that the user is entering 10.0. You don't print that on the screen. The user will type 10.0 or something else. That changes from execution to execution. This is something that some of you seem to be confused about. The program is not displaying this, the user is typing in this. Then the program is displaying this message and the user is typing in something. If those inputs are read, or when those inputs are read, the program displays what it read in a message like this, and some information computed from the values it read. So it prints length 10. You cannot write something like I read in 10 or some such thing. You have to follow this precisely. If you don't do that in the lab, you will lose credit. Okay, it has to be like this. And the purpose of printing the length and width to the user is to tell the user what you've read in, so that the user is not confused or not sure what kind of data that your program worked with. And then the program is supposed to compute the area and perimeter and print those things too. So you have to meet the user's needs, not tell them like, this is what I'm going to give you, take it or leave it kind of stuff. That is not going to work out in this field. Now, whenever you write a program, it is your responsibility to ensure that it works. When you are a programmer, that is part of the job. It is not enough to just code something. It also should be working correctly. If you download a program, if you buy a program, you expect it to work correctly. How do you do that? By creating test data. So I ask you to create sample data that will be used by you to test the program to see whether it is going to work. This is an example of test data. If I give a length of 20 and width of 5, I expect the output to be like this. The area would be 100, perimeter would be 50. So I want you to give different values here, not 20 and 5 or 10 and 8. You have to use different values and tell me what you expect. Then you write the pseudocode. Pseudocode is not the same as Python code. If you write Python code here, you won't get credit. Okay. Pseudocode is meant to help you solve the problem. Many students tell me that writing pseudocode is very hard for them. That is true. I agree. The reason is at that point you are thinking about the problem, not just writing some stuff. It is not like putting nuts and bolts together. You're thinking about the problem, trying to come up with a solution and expressing the solution. That is very hard. It will get easier as you progress through the course, but initially it is a different way of thinking. It is very hard. Don't write Python code. Don't write length equals float input or that kind of stuff. Don't expect to get credit. That is not going to happen. Then some students are confused about this. This is just cheat sheet, nothing else. If you find yourself writing something like this in your pseudocode, this is how you convert it into Python code. That is what this means. Don't assume that this is required in the program. If you some students just type this up, or at least one student typed this up, whatever is appearing on the right hand side, it doesn't make any sense. That is not what this is supposed to be. Use ideas from below, right? So if you have something like input an integer into x is the variable you are reading into, then this is how you would write it in Python. It's a lot easier if you have things like algebra, because then you can use Python statements more directly. That brings me to another point. Some of you had written things like add a and b to get x, multiply a by 2 and add to 3 times the value of something, etc., etc. Don't write like that. Nobody writes pseudocode like that. You would write it using algebra. If you write using those English language statements, you will lose credit in this lab and in pseudocode for assignments, because that is not the way to write pseudocode. You would write set x to a plus b. You don't say add a and b to get x. No. You write it like this, much simpler to understand. Okay. Then, yeah, the other thing is, there is only one set of code. Some students have written multiple sets of Python code for assignments. That is not correct. You write one program and run it repeatedly to test. For example, let me write a program here. This is a mistake that more than one student made, so I want to talk about that. So here, I'm going to create a new program. This is like the lab from last week. Not may not be precisely as I had asked, but very close. So let me save this file and okay. So you could say number of credits equals int input enter number of credits. When you type in, make sure that you have matching parentheses. If you have two left parentheses, you should have two right parentheses. If you have a beginning quote, you should have an ending quote. Those kinds of things you should worry about. Tuition rate, float input. Don't put int input because this can be having decimal points. So input tuition. Then total tuition equals number of credits times tuition rate. You have to spell them correctly. One way to ensure that is to copy and paste the variable names, and then print number of credits I'm just abbreviating things so that I can save a few seconds here and there, nothing more. So that is my program. There is only one set of code to read in the number of credits, tuition rate, compute the total tuition, and print out the result. I didn't put any numbers like 10 or some such thing here. That is not what I should be reading. I should be simply asking the user what the number of credits is. The user types in some value, and that goes into number of credits, right? Now I run this 10, 36.5 or 26.5, whatever. Then if I want to run it for another number set of values, I will run it again, 20, 10.5. Okay, I can keep on running this for as many pair of numbers as I want, but there is only one set of code.
I have a question.
Yes.
So you put the values after you already, okay. So you run the program, that's when you put the values, right?
Correct.
So if you put the values right now, like on the number of credit, it's not gonna run, right?
Where you mean here?
Yeah.
You should not. I am asking the user for the number of credits. Whatever the user gives is what I am storing. I shouldn't be writing things like this. This would be wrong. I don't know if that is your question, but number of credits. This would be wrong.
Okay.
Yeah.
All right. Thank you.
Yeah. Any other questions? This is mighty important. You have to get it not after this class, not tomorrow, not even an hour later, right now. Okay. This is mighty important. Because you don't know what the number of credits taken by the user is. That is why you are asking. You can't decide it is going to be 10 or 15 or 20 or any number. It is for the user to decide. The user says, I am taking so many credits. Okay. You wouldn't like it if your registration system always charge you for 16 credits or whatever, right? If you're only taking 4, it shouldn't be charging you for 16. Then you would be a pretty unhappy person, all right? That is the point.
Thank you.
Yep. Okay. All right. Then I think I'm done with most of the stuff, but I want to emphasize one thing. It is important to master the material on a weekly basis. Be patient, but work on everything that you see each week. Don't postpone it. If you postpone it, you will regret it. There is, if you don't understand what is happening in a particular week, next week's material will make no sense. And if you don't understand what is happening next week, then the week after that won't make sense. Soon you will lose credit, you lose interest, I should say, lose interest, and then either you don't do well in the course or you drop out. Either way, it is not a happy result. And the time that you have to be most worried about is around weeks 7, 8, 9. Around that time is when a substantial number of students just drop out of the course. The reason they drop out is because they haven't bothered to master the material. It's a fact. I have to tell it bluntly. They don't bother to master the material that came before. They think everything will just somehow make sense. They allow things to drift. And things get very difficult around week 8, around that time. Things get, after the first exam, it will ramp up. 6 and 7 would be a little difficult, but then 8 and 9, it will get extremely hard. At that time, if you don't understand, many of you, some of you won't understand if you, because you don't pay attention in the initial classes. If you don't master this material, that would be an impossible job, but it doesn't have to be that way. That is the important thing. That is the thing that you should take heart. I mean, if you do this on a weekly basis, master every piece of material on a weekly basis, you will be fine. Let me assure you, those who drop out are the ones who neglect the subject material. They don't watch the videos. They don't do the labs honestly. They don't participate in the class exercises, and they don't understand the material. And very soon you will have it. Nothing will make any sense. I have seen students who come to class without watching any videos. They had no idea what is going on. Then I can't really help them. Okay. Yeah, I will try to help you to the extent that I can, but I cannot do your work. It has to be done on a timely manner. I'm not kidding here. All right, it is not something that you can just study for an exam and then be done. That is not going to happen in this course. Okay. Yeah. All right. What else? I don't have anything else regarding previous material, but I would like to spend some time on the new material. So let me, but not a whole lot of time, but I want to emphasize certain things. You should have watched the videos, understood what is going on, but I will go over some of the more important aspects of what we are doing this week. Any questions as I am trying to get organized here for the next part of the presentation? Anybody? All right, then let me. Some of this material you have seen before. So, I mean, in the last week or so, but some others you probably have it. Okay, here you have seen all this in last week. Like you have a variable on the left-hand side and you assign values. They move from right to left. Counter equals counter plus 1. You can't write a plus 1 equals 10. That doesn't work in computer programming. Of course, if a plus 1 is equal to 10, a has to be 9, but that it just doesn't work that way, right? You have to write a equals 9, not a plus 1 equals 10. You need identifiers for variables that store values. They should be meaningful. So you should write things like tax rate, smallest number. Okay. Identifiers can begin with a letter or underscore, and they should be followed by letters, underscores, and digits. You cannot begin with a digit. You cannot put ampersand, question mark, etc. The only special character that you can have in a identifier is underscore, nothing else. I discourage you from using underscore as the first letter of an identifier. You might get into trouble with Python. Don't do that. All identifiers have to be meaningful in this class. There are certain identifiers called reserved words that you cannot use in your programs. You cannot use for, if, true, false. There are many such reserved words. They are reserved by Python for special things. They mean something else in Python. So you can't use for and write 4 equals 5. That is not correct. Or if equals 2. Those kinds of things are not allowed. Then there are literals, like 3 is a literal. 0.4 is a literal. Negative 7.5 is a literal. 4.5, winter in quotes is a literal. You can't put a comma in a number. You don't use this. This cannot be a literal. Winter is not a literal. It could be a variable perhaps, but not a literal. If it is to be a literal, it has to be in quotes. Now, yeah, let me go ahead and share my whiteboard. That is what is required here. Okay. When you write something like x equals 5, what happens is, behind the scenes is, here is your computer, and part of the computer has your program occupying some memory. So there is some memory, your program is here, and it has some memory, and the memory is divided into cells, like bytes. So they start at 0, then they are numbered 0, 1, 2, etc. You can think of it like that, 3, and so on. So there is a variable for x in Python. X has some space. So it calls this x. It is at some location, I don't know, you don't know. It depends on Python, right? Python puts that x somewhere, then the value it puts somewhere else. And then says, x has this value. How does it do that? You saw that these cells have numbers. Those are called addresses. So every cell has an address starting at 0. So this 5 would be at some address. I have no idea where it is going to be. Let's say it is at address 10,000. then this X will say, my value is at 10,000. So it is like this. X is telling to find the value that I have, go to location 10,000. And in 10,000, I have 5. So this is something like when you go on a street, you might see 94, right? I-94, the symbol. This is not the highway. This is simply saying, or maybe there might be an arrow like this saying, go this way to get to I-94. That I-94 is somewhere here, right? So this, if you follow that exit, it will take you to I-94 and you will join that. So this part is like this board here, signboard, saying where I-94 is. This is telling where X value is. This is the actual highway. Like that, this is the actual location of the value of X. And that can change from time to time. If you change X to 6, that 6 might be stored somewhere else, right? So like that, this is telling where I-94 is. This X is telling where its value is. So it is useful to have that idea right now in your mind, and it will help you understand the material more clearly as we progress in this course. So when you write X equals 5, we sometimes write it like this. X is pointing to 5. X is pointing to the location that contains 5. X is called, this is a reference, and this is called an object. X is an object. Everything is an object in Python. That is one important thing. The other thing that I wanted to talk about is, it is in the slides too. You use plus for addition, minus for subtraction, star for multiplication, just like normal algebra. But for division, there are 2 divisions. One is putting 2 slashes. The other one is to use a single slash. So if you write 8/3, 3 goes into 8 2 times, result is 2. But if you write 3/4 with a single slash, the result is 0.75. This is floating division or real division. This is integer division. So there are 2 division operators. Then another one is the mod operator. What does it do? For the moment, you can think of it as remainder. For example, if you write 11% 3, what happens? The result is actually 2. Why is it 2? How does it get to be 2? Well, 3 goes into 11 3 times. All right, 3, 6, 9. There is no 4th time. It is only 3 times. So after that, there is something that you can't really divide by 3. That is 2, right? 3 goes into 3 times. So that takes care of 9 of the 11. Then there is 2 remaining. And that is what this operator gives you. So for example, if you had 16 cookies and 3 kids, if you divide the thing evenly, every kid gets 5 cookies, right? that you can get by number of cookies by number of kids, right? If you have 16 cookies and 3 kids, it will give you the answer as 5. But then what is remaining? Remaining is 1 cookie. And that is what 16% 3 will give you. The cookie that is remaining. It is a little more complicated than all this, than what I am making it out to be. It is, the mod operator is actually a little more complicated, but for the moment, it is best to understand it as remainder. There is a more involved definition, which we will not go into at this point. It's not worth it at this point.
I have a question.
Yes.
So does the double slash sign work the same way?
A double slash simply gives you the quotient. So for example, if you have 16 cookies and divide it among 3 kids, this is the number of cookies left, but 16//3 would be the number of cookies that each kid will get. So this would be 5. Whereas 16% 3 would be 1. Do you see the distinction between the two?
Yeah.
Okay, but was that your question?
Yeah, it was.
Okay, very good. Then, yeah, the other thing which is very easy to see is star is what you use for exponentiation, right? If you want to take the power of 2 with 3, 2 to the power 3, you write 2 star 3. Some students think it is 2 caret 3. That is not going to work, right? Sometimes you write it outside of Python like this, but don't write it in Python. You have to use 2 stars. And everything is evaluated from left to right, except certain things. For example, star is evaluated from right to left. So if you write A star B star C, then you do this first and then get the result and then raise A to that power. It is not for A to the power B, which is raised to C. That is not how it works. It is B to the power C applied to A. Whereas everything else works from left to right, plus, minus, star, slash, percent, etc. work from left to right. And you can override things using parentheses. Those are things in algebra we don't need to spend a lot of time on. Now, the last thing that we want to emphasize is, give me a second, my machine is not charging. Okay, yeah. All right. The last thing that I want to talk about here is, sorry. Something happened to my pen. Sorry. Bear with me for a second. Sometimes I press the wrong things and then it gets stuck. Let me try to get this fixed. No, I'm not able to get it done. So I'm going to use Word here. Sorry about that. Okay. Yeah, the last thing that I want to talk about is how you store stuff in the computer, inside the computer. You see, ultimately, inside the computer, you only have electronics, and electronics is not capable of understanding English or anything else other than voltages and current, those kinds of things. So there is only one thing it can do. It can sense whether something is high voltage or low voltage. High voltage means 5 volts, perhaps. So whether there is something, whether there is some voltage in some place or no voltage in some place. So if in your memory, it will be like you have a lot of cells, memory cells, and each memory cell is having a voltage or no voltage. So it will be like this: voltage, no voltage, 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 no voltage, no voltage, 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 no voltage, no voltage, no voltage, no voltage, 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 like this. Some cells have voltage, some cells don't have voltage. And this is data, program, everything. So the electronics has to make sense out of these ones and zeros, right? How does it do that? Well, if you have a number, so to understand that, let's look at how we make sense out of symbols. When you write numbers, you use 10 symbols, right? 0, 1, 2, etc., all the way through 9. There are 10 symbols. So if you write something like 25, that you use 2 and 5, and what does it really mean? It means 2 times 10 plus 5 times 1. That is what it means. Or if you have 789, it means 7 times 100 plus 8 times 10 plus 9 times 1. Right? Because there are 10 symbols, we write like this: 100, 10, and this is 1, which is actually 10 power 0. So instead of 1, we can write 10 power 0. So we have 10 power 0 and 10 power 1 here. We have 10 power 0, 10 power 1, 10 power 2. Then if you had more larger numbers like 8,634, it would be 8 times 10 power 3 plus 6 times 10 power 2 plus 3 times 10 power 1 plus 4 times 10 power 0. So you have powers of 10 multiplying these individual numbers, and you get the total value like this. Similarly, if you have in the computer world a number like 110, what does it mean? What it means is 1 times the leftmost 1 times 2 power 2. See, we have 2 symbols. So instead of using 10, I'm using 2. Plus 1 times 2 power 1 plus 0 times 2 power 0. So what is going on? Let me increase this. 110 is the value inside the memory. So I take the leftmost one. This is the leftmost one, multiplied by 2 power 2. Why 2 power 2? This 2 is because there are 2 symbols. This 2 is because the rightmost digit has a power of 0 The one in front of it has a power of 1. The one in front of it has a power of 2. So since we are talking about this particular one, its power is 2. So this one is carried over here. This 2 is because we are in the world of binary values, 2 values. In the decimal world, we have 10 values. Then this power is 2 because that is the power of that position. Now this one comes from here. You multiply it by 2 power 1. This 2 is always there because that is the binary world. And the power here is 1 because this is the second position from the right, 2 power 1. Now, here the value is 0. We still use 2, but the power of that is 0. So this turns out to be 4 plus 1 is equal to 5 in the decimal world. So if you take any number, if you take any binary number, you can find its decimal value by this process, using this process. So that is not a problem. Finding a number corresponding, finding the decimal number for a binary number is no big deal. But what happens when you want to store things like Tom, Dick, or Harry in your computer system? These are not numbers, these are letters. What if you wanted to use to store equals or semicolon or double quotes or ampersand? These are not numbers. So how do you store them? You only can store ones and zeros inside the machine. On a piece of paper, you can scribble anything you want, but that is not possible inside the machine. So how do you store all this? Again, you have to resort to these ones and zeros. So how? Well, what we do is we assign numbers to all these characters. Like T has a number, O has a number, M has a number, equals has a number, semicolon has a number. Everything has a corresponding number associated. That is called the code point. So every letter on Earth has a corresponding code point inside the computer. Whether it is a letter in English, a letter in Greek, or Latin, or Hindi, or Urdu, or Arabic, or Japanese, or Chinese, Romanian, Hungarian, doesn't matter. There is a corresponding number associated with it. For every number, for every character, there is a corresponding number, and that is called the code point. Somebody has decided, a committee has decided that. It is not just one individual who decided it. And it was not pre-arranged. So people sat down and then came up with a set of code points for every character on Earth. So if you write something like this in your program, name equals Tom. Okay. Suppose you had code like this in your Python program. Then what happens is, in the memory, it puts code point for, what Python does is it puts the code point for T, followed by the code point for O, code point for, it stores 3 numbers, one for T, one for O, one for M. So the memory for this variable name will actually have 3 numbers. One for the letter T, one for the letter O, one for the letter M. Of course, those would be in binary. So if the letter, if the code point for t is like 85, it will be expressed in binary format. So how do you find the code point for something? There is no magic. Google. You look for the code point for a particular number. I don't know. I don't remember. I mean, nobody can remember. Not even the people who developed this would remember. You have to go to a table, right? So that is what you do when you want to find the code point. There is no other way. Any questions? Okay, in that case, let me stop recording here. And